So in the last module, we were looking at how to understand the results of such a typical screen analysis, where you are given in the first column the size ranges in this format, that is Tyler mesh series format. Okay, and you are also given another column where you have mass fraction region for each of the ranges of your Tyler mesh. Notice here that it is size range. Okay, that will be important for the next part. If you have any questions about how to analyze this sort of a table, then revisit the last module, that is sieve analysis, and then come back to this module. Okay, so we are going to look at 4 different ways of displaying these results in graphical format. Okay, so what are these 4? The 4 ones, first one is histogram, second one is cumulative distribution curve, third one is fractional distribution curve, and the last one is semi-log or log-log plot of the fractional distribution. Okay, so if you remember from statistics, what is actually histogram? Histogram is a little different from a typical bar graph. A bar graph will give you the bars which have equal widths. Histogram is not like that. Histogram is something that has class and class boundaries. If you have any problem with this, revisit any statistics book or go to the Wikipedia and any other source and look up what is class boundaries. For our purposes, our x-axis will have the class boundaries and the y-axis will have the mass fraction of particles, which have sizes larger than dp1 and smaller than dp2. Let's see what that means. So, as we already know that this type of typical screen analysis can be represented as a histogram. Okay. In your histogram, like we already said, the x-axis will have the size ranges which we can get from this table, this column, and the y-axis will show the mass fraction which we can get from this column. Okay, let's just do it like in a demo. So this is our table and this is what we're supposed to get at the end. So I have already drawn the axis. So in the x-axis it is particle dimension dp inch. Now whenever you draw this sort of graphs, please make sure that you have the axis label. If you don't write the whole thing, at least write the symbol, write the units. Same thing here. If it's unitless, that's fine. And your axis numbers. Okay. So let's look at the first point. We have minus 10 plus 14. This means that the 2% of our particles are falling through the 10th sheet and on the 14th sheet. So 2% of the particles has particle diameter which is greater than the 10C hole but lower than the 14C hole. So if you look at the axis, that's what it's showing here. You can take, for this we need the chart. So you have 10 means 0.065, 14 means 0.046. So 2% of my particle is having size of range greater than 0.046 but lesser than 0.065. So when we plot that as a histogram rather than a typical curve, we can actually have a class range. So 0.065 starts from 0.065 and ends up to 0.046. And what about how much is the height of this? 2%. And if you take in mass fraction, it's 0.02, somewhere around here. So that is my first class boundary and my first bar for my histogram. Okay. So let's go to the next one. The next 5% falls through the 14 mesh and sits on the 20 mesh. So that means 5% of my particles can fall through the 0.046 and sit on the 0.028. That means that these particles have particle dimension greater than 0.0328 but lesser than 0.046. That and we can write 0.046 we already have here. And the other one, the relevant one, is 0.0328 somewhere here. So I get my class boundaries. These are my class boundaries. What about the height? The height will be 5%, meaning 0.05. So that's my second one. Okay. So the next one is 10% of my particles falls through the 20 sieve and lands on the 28 sieve. Coming back to my chart, I have 20, 0.0328 and 28, 0.0232. So if it falls through 20, that means the particles are smaller than 0.038 and larger than 0.0232. So I can just I can write 10%. So next one, 18%. If you look from the chart, 28 and 35 is giving me 0.0232 and 0.064. So 0.0164. 18 here, and then 25%. Here. I'm going to stop here and I'm going to let you finish the curve yourself. Okay, and the final curve should look like the one that you have in the book and in my slides.